topic that we need to understand before we actually start the programming is the instruction set. Now, I think all of you are aware about what exactly is the instruction, right? Instruction. One of our discussion we discuss about instruction set in digital electronics. Basically, instruction set is basically it gives you the commands, or it is basically the operations that we can carry out using basic microprocessor, right? So it is used to understand what all operations are possible by your hardware, right? Now, your control unit or whatever, whenever you face the instructions are actually represented in binary, right? Whenever we store it in memory, those are actually stored in binary format, zeros and ones. But for a programmer, right, whenever if I want to write a program, earlier they were used to write zero in the program in zeros and ones, right, with 8085 and all. They used to key in the hex codes, right? But with the development with the assemblers, right, there these instructions itself we can just write it in text file, right, or the source file, and we can assemble and we can convert it into binary file, right? In 8086, 8085, we have the instruction set, right? Now, these instructions are basically the English like words, right? So for a programmer to understand what operation it is going to carry out, right, these binary formats are converted into English like words. So it will make us easy to write the assembly code, but processor don't understand these instructions, right? Move and all. So if you just pass MOV to CPU, it will not understand. But if you pass the opcode of MOV, then your processor will understand. So that conversion, it requires your assemblers. And writing assembler is the job of computer engineers, right? So you need to understand what structure, right? So whenever you write move, then your assembler should understand that it is a move instruction, and then we should convert it into its binary equivalent. Right. So then when you work with the compiler design and all, or assembler design and all, you will understand that how these keywords are basically converted into binary equivalent, right? And what all options are there. All right. So here we will talk about the different instructions. So here these are the instructions, right? So total 11 categories are there as per the manual which is present from the Intel. Right, these are the different instructions which are present: data movement, binary arithmetic, decimal arithmetic, logical, control transfer, string and character translation, instructions for block structured language, flag control, coprocessor interface, segment registers, instructions, and then miscellaneous instructions are also there. Right, so we will cover one by one with this. Now, when you talk about the data movement instruction, it is mainly used to move data from one place to the other place, right? Now, there will be always one confusion, right? Many students used to ask, like, whenever I'm moving data, is it really moving or it is copying? So when you write move instruction, it really copies the data, right? The source value will remain as it is. It is not going to modify it, right? So here, whenever you use move instruction, it is copying the data from source location or source operand to the destination operand. It's a very simple instruction, right? So this is the way by which we can move our operand, right? So as we discussed, that basic fundamental data types are byte, word, and double word. So we can use move any of the data depending on the requirement of our program, right? So there are various classes of these instructions. One is general purpose data movement, the second one is stack manipulation, and then the third one is a type conversion. So we'll see one by one, right? Now, when you talk about the general purpose data movement instructions, then in this case we have first instruction, that is move, M-O-V, right? So in bracket it is written M-O-V-E. Let me tell you, like when I was for examination in other college, right? And my habit of assessment during examination is I used to give first 10 minutes for writing the statements, writing the algorithm on answer sheet, and then later on after 10 minutes I used to ask students to start writing the programs. Then after 15 minutes, once they start the exam, I used to move around the lab, right? Then by watching the first few lines, right, we can understand that what is the skills that the student have acquired during the last semester, so that he is writing the program, right. So many students, like I have observed that from that college, many students are writing move instruction as MOVE, right. They were not writing MOV instruction, and then after half an hour or after one hour, I came to know that all of them got the output of their programs, right. So initially they have written the instruction move instruction as a MOVE, right, in first 10-15 minutes, and then at the end of examination, everyone got the output, right. So that is how the students are learning the things, right. So they were using some network, and through the network they were downloading the code. So that was not expected. So strict action was taken against that particular examiner and all. So it happens. But now when you work with the instructions, right, you need to understand the exact syntax of it, right. So here move instruction, it is MOV, right. So MOV is basically the syntax, right. And with MOV instruction, we have two operands. We have how many operands? Those are two operands, right. So as an example, if you write, we can write, there is an example like move EAX comma EBX. Now when you write this instruction, this is a standard format, right. MOV, it is the opcode. EAX comma EBX are the operands, both are operands. Now in this case, EAX is basically OPR1, right, operand 1, and EBX2 is OPR2, right, operand 2, right. And this MOV, we can write it as OPC, opcode, right. Now when you are saying OPR1, operand 1, EAX, it is basically a destination operand. It is basically a destination operand, and EBX is a source operand. What we are doing, we are moving from source to the destination. So from OPR2, that is EBX, to EX, the data will be copied. So here in explanation, it is written that moves content of EBX to EX. But as I told you, it is not really moving, it is copying, right. Now there are different combinations of operands which we can write here, and there are some restrictions as well, right. So here what operand combinations are possible? So to a register from memory, so I can move data from memory to a register, right. Then to memory from a register, so from register I can move it to memory. Bro, between general purpose registers I can move, right. Then immediate data I can move it to register, so that is also valid option, right, the operand combination. Then next one is immediate data I can move it to memory, so this is also valid combination. Now which is not allowed? So the in this point it is mentioned memory to memory move is not possible. What it means? Memory to memory means from one memory location I cannot move data to the other memory location using this move instruction. There are other options we have, but here with normal MOV instruction it is not possible. All right. Now other restriction is segment register to segment register. So one segment register to segment register we cannot. All right, segment register to segment register we cannot move the data. So these combinations are not possible. All right. Now there is a move S instruction. Very interesting instruction it is. It is mainly used in string manipulations while we are handling the strings. Then move S is used. So S represents string. No. So this is move S is opcode. Along with that, there is one more character which is added, and in detail we will discuss later on. One more character is added along with S, right after this, and that represents the size of operand. That represents size of operand. Now there is very interesting point that I will highlight here. Right now, all of you focus on the example which is written here. In this example, what is written? It is written move EAX comma EBX. Right now I explain about it, it is already written there. So can anyone tell me what exactly this instruction is going to do? I explained about it, so can anyone explain what move EX comma EBX will do? Unmute yourself those who want to talk. this basically blank duration is not expected, right? Ultimately it will be wasting time. So immediately you have to unmute and you can start speaking. Move ex comma ebx. What will happen with this instruction? Piyush Ingle, are you there? Yes, Piyush. I asked a question, right? What move eax comma ebx will do? So what are your views about it? Move eax comma ebx. This is move eax comma ebx is the instruction. So what happens with this? So it was presented in the move eax comma ebx. What is going to happen with this? Here I have explained it and it is already there on the screen. So it is going to move what? EBX to EX, right? All of you, you just give your remarks. Is this correct? All of you? Shreya, Paitankar. Shreya, are you there? Shreya Paitankar. So what is your view about it? Is this correct answer? Okay, all right. So it is correct, right? So I think all of you are there, right? What do you see when you say you are moving content of EBX to EX? How much data it is really moving? How much data it is really moving? So who will answer this question? How much data with this particular instruction move EAX comma EBX? How much data will be moved? How much data? So I think Bhushan is there. Unmute yourself and give your answer because don't waste time in typing and all. Bhushan Munot.
Yes, sir.
Yeah, how much data it is going to move with this move EX comma EBX? The explanation of the instruction is given by Piyush, right? Move the content of EBX to EX. But how much data it is moving? That is my question. The instruction is given here, right? Now to give this answer, what basic understanding we need to write? Okay, 4 bytes are there, but off memory is not correct, right? It is correct 4 bytes, but off memory is not correct. Why? Because when you just read the instruction, it is both operands are the registers. So from one register to other register, it is moving. Now, why you said 4 bytes? Because see, why 4 bytes? Because as we discussed, if I explore this EBX, which is our source register, it is a 32-bit register, right? So ultimately, it is a 4-byte register, right? Now, additional to this, we have BX register, right? Which is part of your EBX, which is 16-bit register. Now this is 16-bit register, right? Its size is 16-bit, that means 2 bytes. All right. And half part of it is BL and BH is there. BL and BH is there. And both are 8-bit. Both are 8-bit register. So ultimately you can understand the size of data which is really moving. right? So this I explore. I just divided EBX in parts. So EBX is divided in two half, right? Higher word and double word. Lower word, higher word and lower word. Lower word is BX, labeled as BX. Then BX further it is divided in two half, in 2 bytes. Lower byte is called as BL and higher byte is called as BH. So byte is of 8 bit, word BX which is there, right? It is of 16 bit, and EBX itself is a 32 bit. Now, depending on the operand that we are using, we can easily conclude that how much data it is really moving, right? And all of you should understand what exactly I'm talking about. If you have doubt, I will explore more, because once you get clear idea about the register and its sizes, then based on that you can easily understand the size of data which is manipulated or handled by that particular instruction. So with these 3 lines, any doubt in your mind, please ask. I will spare 2 more minutes for this. Any doubt on this? Everyone got this particular point? Like EBX, we have 3 more registers, right? Those registers are EAX, ECX, and EDX, right? Which are all again having same structure, right? So like EBX, we have this additional 3 registers. All right. Getting this. Now let me continue with my presentation. Right now, when you are talking about MOVS, there is an additional size, character which is added here along with MOVS. Then the options, 3 options we have, because we have up to double word operand. So we have MOVSB, MOVSW, and MOVSD. Right. So what this B means, MOVSB is the instruction, right? So it is move string byte, right? Move string byte, right? Then MOVSW. So here it is move string word. So here the interesting part is operand is, operand size is changed. If I want to move byte value from one string to other string, then I have to use byte MOVSB, right? So that I can move. So this defines the size of your string, right? So if you are handling a string which is of byte size, then you have to use MOVSB. If your string, each element size is of word, then in that case we have to use MOVSW, and then move, then SB is there. So this is a double word, right? So it is basically double word. Move string double word. All right. So here B, W, and D is associated to what we have written here, right? So here, what we have written here, we have written that byte, that means 8-bit, word means 16-bit, and D means double word, that is 32-bit. All right. So here you will come across this particular information, right? This information will be, very much useful whenever you do programming with assembly code, because by just observing the register combinations that we are using, we should be able to understand what data it is moving or what data it is manipulating. All right. Now, there is an interesting point that I will ask, right? So I will put that question in chat box. All of you can just note down in your notebook, right? So what we'll do, I will just give you example here. Now, in earlier example, I wrote AX comma EBX. Now I'm writing AX comma BX. Right. Now, what is the difference between the earlier instruction and this instruction? In this instruction, it is moving 16-bit data from BX register to AX register. Right. Then, if I write AL comma BL, in this case, it is moving 8-bit data from BL to AL. All right. Now, Let me write one more instruction, move AH comma BL. Now, is this correct instruction that I want to ask? Right? Is this correct instruction? Move AH comma BL. Is this correct instruction? That is the question. Chetna Thorat, are you there? Chetna? Chetna Thorat.
Yes, sir.
So I see. I wrote few instructions on in chat box, and I've written total 4 instruction we discussed, right? Move EX comma EBX, which we've already discussed. Then here I wrote move AX comma BX. In which 16-bit data I'm moving it from BX register to AX. Then next instruction I've written is move AL comma BL, in which 8-bit data from BL I'm moving it into AL. And then I asked that I've written move AH comma BL. And I asked that is this the correct instruction? What is your view?
Yes, sir. It is faster than the previous one.
Faster, okay, not really the faster, but ultimately it is the correct instruction. There is no issue, right? It is not mandatory, right? What I'm doing, I'm just moving 8-bit data from one register to other register. All right. So these combinations we can have, but only parameter or only restriction is. Now I am writing one instruction and say I am writing ECX comma DX. This is the instruction that I am writing. Now, what is your view about this instruction? Is this correct instruction? First question. If it is correct, then how much data it is moving? If it is not correct, then why it is not correct? Move ECX comma DX. Who will give answer? Who will give answer? Shubham Jadhav. Shubham Jadhav.
Yes, sir.
Okay, Pritesh already put his remark. All right. See, Shubham, the question I asked was, is this the correct? So Pritesh already gave the answer, right? No, because it's moving 16-bit to 32-bit. Now here it is mandatory to have, for move instruction, it is mandatory to have, or there are several instructions in which both operands should have same size. Right, both operands should have same size. You have to keep this thing in your mind. So ultimately, here we are moving, we are trying to move 16-bit data from one register to the 32-bit register, and that is not possible. So with the move instruction, and there are some arithmetic instructions in which we need, it is mandatory to have both operand sizes should have same sizes. Both operands should have same sizes. All right. But then there are few instructions where you may get confused. Right. So if I write move, say EBX, comma, say immediate value I am moving 5. Right. I am writing this instruction, then I am writing move BX, comma 5. Then I am writing move BL, comma 5. See, 3 instructions I have written. You can just go through these 3 instructions, and you can tell me which instruction is correct and which are incorrect. What are your views? You can just unmute yourself. Who will give answer? Swapnil Lad. Swapnil, are you there?
Yes.
Unmute yourself. See in chat box, I have written move 3 instructions: move EBX, 5, move BX, 5, move BL, 5. I want to know which instructions are incorrect, which instructions are correct. See here in this case, immediate value, this is 5 value, right? It is an immediate value. So here, Chinmay, your answer is correct, right? 5 as a numeric values to respective destinations. So here it is moving 5. So now, instruction wise, the size of this 5 is going to change because it is an immediate value. And by just adding zeros on left side of 5, right, it is not really going to modify the value, right, the magnitude of that number. All right, so here when you are using bx comma 5, that means it is moving, right, what it is moving, it is moving 0 0 0 0 0 0 0 5 to ebx. So when this instruction gets assembled, in that case it will be really converted as 0 0 0 0 0 0 0 5, right? So this is the actual instruction which will be converted into machine code. In this case, it will be converted as 0 0 0 5, right? And in this case, it will be now this is the job of your assembler, right? In such cases, now these are the actual instructions which will be really converted into machine code. All right. So here, when we are handling with the immediate value, right? Immediate value can only be at source location. You cannot have it as a destination, right? So if I try to write move 05 comma BL, so this is incorrect, right? This is incorrect. This you cannot have. You cannot have immediate value as a destination. All right, because immediate value is not having any storage space as such, right? So here it is not a register, it is not a memory location. So ultimately it will not be, it is not valid instruction, right? So with these data types and all, I think